Welcome back to our study of solving equations. We have many more types of equations that need to be explored. We're going to start today with polynomial equations. Now you may wonder if our study of linear and quadratic equations was sufficient for a study in terms of polynomials. But as you're going to learn, polynomial equations extend far beyond the 1 and 2 degree equations we've learned in the past two chapters. Let's start by looking at the equation x cubed minus 25x equals 0. This equation isn't a quadratic or a linear equation because its highest degree is 3. Therefore, it's a cubic equation. Because it's a cubic equation, we no longer can employ our use of the quadratic formula here. While a cubic formula does exist, it's much too advanced to be used practically. Since our equation is already set to 0, let's start with seeing what we can first factor. Each term has an x, so let's start by factoring it out. X times x squared minus 25 equals 0. Notice what we have now. A linear x equal to 0 and a quadratic binomial equal to 0. This is in the form of AB equals 0. So we can use the zero product principle here. If A equals x, then x equals 0. That's simple enough. Then if B equals x squared minus 25, then x equals plus or minus 5. So our solutions are x equals 0, negative 5, and 5. Notice that we got 3 solutions for our cubic equation. We can see that if we have an equation of degree 3, then we should receive 3 solutions, just as a quadratic gave 2 solutions and a linear equation gave 1 solution. This is a core subject of interest that we'll explore when we study polynomials later on. But as a teaser, what we can say now is that we should get no more solutions than the degree of a polynomial. The next few examples will show how we can still use the zero product principle to solve similar equations using the same method. Number 1. 5x to the 4th power equals 45x squared. Here we have a polynomial equation in degree 4. Let's put it into standard form by equating it to 0. 5x to the 4th power minus 45x squared equals 0. Notice both terms have a factor of 5x squared. So we'll factor that out. 5x squared times x squared minus 9 equals 0. We now have an equation in the AB equals 0 form. So we can solve using the zero product principle. If we let A equals 5x squared, then x equals 0. And if we let B equals x squared minus 9, then x equals plus or minus 3. So our solutions are x equals 0, negative 3, and 3. Number 2, x cubed minus 4x squared plus 4x minus 16 equals 0. This is our first time seeing a full-length cubic equation. Don't worry, it won't be difficult at all to solve. We're going to factor this using the grouping method. Let's look at the left side of the equation in 2 parts, the first 2 terms and the second 2 terms. With the first 2 terms, x cubed minus 4x squared, the only factor we see is x squared. Then when we look at the second 2 terms, 4x minus 16, we only see a factor of 4. So let's factor those out of our terms. X squared times x minus 4 plus 4 times x minus 4 equals 0. Notice how after we factored out our common factors, we're left with 2 terms with a common binomial factor, x minus 4. Let's factor this binomial from each of the 2 terms. X squared plus 4 times x minus 4 equals 0. We've successfully put our equation in the a, b equals 0 form. Using the zero product principle, if a equals x squared plus 4, then x equals plus or minus 2i. And if b equals x minus 4, then x equals 4. Therefore, our solutions are x equals 4, 2i, and negative 2i. Notice that even with polynomials of degree 3, we were still able to get complex numbers in our solution. Number 3, x to the 4th power minus 3x cubed minus 4x squared equals 0. We should have a pretty good idea of how we can solve these equations now. This is a degree 4 equation with only 3 terms. Notice that all 3 terms have a factor of x squared. Let's factor it out. X squared times x squared minus 3x minus 4 equals 0. Once again, we have an equation in the form of a, b equals 0. Notice that this time around, we have a quadratic as one of our expressions. If we let a equals x squared, we get x equals 0. If we let b equals x squared minus 3x minus 4, then after factoring, we get x equals 4 and negative 1. Therefore, our solutions are x equals 0, 4, and negative 1. This lesson showcased once again the usefulness of AB equals 0. As mentioned earlier in our lesson, this is a subject that we'll be studying deeply in a later unit, sometimes called the zeros of algebra. Setting polynomials equal to 0 enable us to powerfully analyze our equations. The AB equals 0 principle is one of the many outcomes from that study. In the next lesson, we look at how we can solve rational equations.